Okay, hello students. This time I'm making a video. Last time I did a video on why integral of secant is ln secant plus 10, and which is same as ln pi by 4 plus x by 2. Also we have seen why integral of cosecant is ln cosecant minus cot, and which is ln of 10 by x by 2. Then after that I made another video which is set to which if you have come across 1 over a square plus x square minus a square, and then we have also seen this. So I'm going to make another video on how to lot of problems based on this. But today I'm going to do set number 3 as the set 3 is about when there is a radical sign square root of a square minus x square. If it is same thing, you switch this x square minus a square, and if there is a plus sign. We need to know all this definition of cosecant, secant, and cot. And good thing is, why? I'll just give an example. If you want to integrate cosine 2x and plus 3 cosine of x and minus 7 dx. So the question is, how do we do the integral of this? So there is a kind of this 3 formula helps, where we can easily try to write cosine 2x as 2 cosine square of x minus 1, get a quadratic type form, where you can, if I change this to as 2 cosine square of x minus 1, and then you can add this minus 1 adds to minus 7, and this will be 1 over 2, and instead of cosine of x I make it a t squared plus 3t minus 8, and then we can easily write this in the form of this way and get the answer. So basically my goal for this video is how did we end up getting these formulas. So starting with the first one. So integral of, so we are going to use substitution method. That's the easiest way to do. So next it is a square minus x, the variable is subtracted, so it is better to replace x by, so let's replace x by a sine theta. So the reason is because we know the Pythagorean triplet that sine square theta plus cosine square theta is 1, and cosine square theta equals 1 minus sine square theta. So those are the ones. So, but in this case there's a square, so I'm going to write down a square, x equals a sine theta. If I'm going to differentiate this becomes a cosine theta times d theta. At the same time, this sign, this is important, right? I'm going to write it as sine theta equals x by a, right? So this would be x by a, and basically what that means is theta equals sine inverse of x over a. So these are the things we need to know before we forget complete. So let's plug that in, that dx is a, so this will go right here, this part will go right here, and this x will be replaced, so the I now will become integral of 1 over square root, and this dx I'm replacing by a cosine theta, so that will be a cosine of theta, and times d theta, then down this will be a square, and minus this one a square, because when you are replacing it by there's x squared, so I'm going to write directly square the a and also sine square theta. Now you see there's a square is common, so we'll pull it out. So this will be a outside, because when I take a square, undo or factorize a square, this is going to be 1 minus a. So you do undo distributive property, and the square root of a square is a. So this 1 minus sine square is cosine square theta. This goes away, you get integral of 1 over cosine theta. So that will give you integral of secant theta d theta. See? Then we can easily write down there's some one, I think I messed up somewhere. X is a sine theta, cosine theta. So this is cosine theta 1 minus sine square is cosine. And I think I missed this cosine theta here. That's the one I missed here, cosine theta. So this is cosine theta. This two crosses out, and you get. I was just wondering. So this is 1 d theta, which is integral of 1 is theta plus c. But what is theta from here is sine inverse of x over a plus c, and that takes care of the first one. Let me do the next one quickly. So this is it's always better to know why this formula exists. So hope that helps. Now this time second one is x squared minus so in this case we will x we can replace we can use the other formula, Pythagorean formula, 1 plus tan square theta is secant square theta. So secant square theta minus 1 is tan square theta. So that's one. Only thing that instead of there's an a there, so let me write down. So I like to make these videos because it's always good to know how the formulas exist. So I like, I'm always inquisitive when I was a student. I had always questions, why this formula, how do you get this? So it's nice to know, even though we know the formulas and we can apply them in different situations. Okay, this time it is x squared this side, and there's a minus a squared. The first thing is, x is in the beginning, so we can think of this secant square minus 1 square type. Only thing we will replace x by this x, let's replace it by a secant theta. Then regular derivatives, the derivative of differentiate x with respect to theta. So dx is a, and the derivative of secant is secant times tangent. And then at the same time, you can write this as secant theta is dividing a both the sides, so it divides a both sides. So that will be x over a. That means, so this is, so now because it's going to be a tan also, it's better to have a triangle like this. So secant is hypotenuse over adjacent, so that's like x and a. So like this is theta, so this will be square root of x squared minus a squared. So if I'm using tan, it will be this divided by that. Now, okay, let's replace. So this dx, the whole thing will be replaced right here. So that will be a secant theta. And this will be x. Now what is x is, we replace this one. X is a secant theta. I can write directly a square secant square theta minus a square. Okay, let's simplify this. So okay, so there's a square we can factorize and use undo distributive property. Okay. So this a square will be taken outside, so that will be, so this will be pulled out. See, this will be 1 here. And square root of a square is a, and this is secant square theta minus 1. But what is secant square theta minus 1 is tan square theta. So this will be, and you can cross out this a, we get integral of, and this will be tan square, and because this will end up to, this will be tan square theta, but because of the radical sign, it will be just tan theta. And you can clearly see that there's a tan in the numerator. So this tan theta and tan theta cross out. We have integral of secant, and from the previous, so the from earlier formula set secant, what is the integral of secant is ln, so that becomes ln of secant x secant theta plus tan theta. Now, let's replace secant. What does secant means? X over a, so this will be ln of x over a, and tan theta is opposite of hypotenuse. It has the same denominator, so write the numerator exactly the same. Then we will use the laws of logarithm. So there is a division, there is a quotient. This is same as x, the numerator, minus ln of a. Now this, since we are already, we use the integral, so there is a constant of integration here, c plus c plus c, and this plus c. Now this is again, the whole thing will become another constant. So I can use the bigger uppercase C, and this will be ln, and plus uppercase C. So what is the uppercase C? It is minus ln of a, this ln of a, and plus c. We are done. So that's all we are supposed to know, that this is what we proved. Now let's prove the third one last. So in place of, so this is c, so put an a here, there's a x squared plus a squared. This will not help. So in this case, we clean this. Just want to make that board clean, otherwise it becomes dark. So we are going to substitute, so in place of x, you can think of what do you think should we substitute here. So secant square minus a secant will never help us. Okay, we can't put sine square or cos square because Pythagorean formulas sine square plus cos square is 1. That won't help. So what are the only options we can think of is replace okay, so let's replace x by, instead of x, let's replace it by a tan theta. So why? What is the reason? So because there's a square, so this, when you replace the square x square, this, so this is like x square is a square and tan square theta, see? So it becomes easy. And then at the same time, this, if we divide by a both the side, tan theta is x over a. Okay. Then we can also think of a triangle opposite of adjacent, and this is the angle, and then if this is a and this one, so the hypotenuse becomes x squared plus a squared, because we need this in the later step. That's it. So now I don't want to write this, but I just wanted to show. Let's differentiate this. So dx is a, the derivative of tangent is secant squared. We will replace this dx right there. So the I is a secant squared theta, and the denominator is, replace this by a square tan square, and there is a plus a square, right? So this theta is just for better write separately. And again, use the undo the distributive property. There's a square here, we can pull it out, put a parenthesis here, so this is gone, so there's a 1, and its radical of this will be just a. So that a square, so I can just cross this out here, because the square root of a square is a, and that will cross out here, and in the integral of secant square theta, and this is under the root sign, right? So I haven't done anything here. So it's like integral of 1 plus tan square is secant square theta. And this is same as, let me write here, integral of secant square theta divided by, this is secant theta. Okay, and again, one of the secant goes, integral of secant stays, and we say this secant integral of, this is ln of, from the formula, earlier one, secant theta plus tan theta plus c, and secant from here we can see, replace this secant as hypotenuse over adjacent, so this becomes root of x squared plus a squared over a, and tan is opposite over adjacent, that is x over a, plus c, and you can do the same thing like earlier, has the same, I'll write x first, and then the x squared plus, because it's a plus, doesn't matter. I just want to keep the earlier you had x first, I just made a mistake here, there should be x here, sorry about that. So we have a plus c, and now you can use laws of logarithm, and minus ln of a plus c, and this you can replace by another c, and you get the answer. So this is the done. So we finished these three integrals. Look at this. The earlier one were without, what is that? So this integral, the set is the same. If you see this one don't have a radical sign. This one has a radical. Almost the same thing. Here there is a square minus x square, a square minus x square. So that's how you get 1 over 2a. So there is a number before ln here. So it is 1 over 2a, but in this problem there is nothing before. So see that sign inverse, there is no number before ln, there is no number before ln, but this formula has a 2a. So you can remember whenever it is an integral of without a radical sign, there has to be something. So if it is a square plus x square, this we know directly, you can remember, you know tan inverse, the derivative of tan inverse is 1 over 1 plus x square. So that trick you can use and say, hey, this is 1 plus x square, so it has to be tan inverse. Only the case you have to be careful here. And this one, integral of a square minus a square, there it is. I would remember this, oh, this is a square minus x square, it's like 1 minus cos square is sine square kind of thing. And you can remember that. This other one, x minus a with the minus sign here, and the plus sign, but the same thing, exactly the same radical is repeats here, look at this. So, anyway, so this is what I wanted to show. So I'm going to make a video of, okay, now that we know how to do this. This is set 2, this is set 1, set 2. So my focus will be, another video is how to use this and how to use this 3 and solve a lot of problems maybe. Hope that helps. And again I say, thanks for watching. So the goal of this videos that I make is why these formulas exist? How did you get them from? Do we just apply them, or is there a reason? So that's the reason I'm making these videos, for future use for my students maybe. And yeah, that's it. So we'll see another set 4 will come up. So we are going to do set 4 is integral, same thing, a square minus x square. So now the denominator is not there, just a radical sign of x squared minus a squared and square root of a squared. So so note down, this will come soon, maybe tomorrow, another 2 days I will show that also. So hope this helps, and we'll see why these formulas help directly. Thank you for watching, and if you like this video, the video that I make like this, which gives me, and I feel very nice too when I show that how things work, it helps. So do click the subscribe button to be part of it, so that you can see the future notification, future uploading of videos. Thanks for watching. Bye.